Hello and welcome to part 3 of the tutorial for Lab 8. Here we're going to look very specifically at what data you're going to collect. If you look at your data sheet, you'll see that there are two simulations. Simulation A is where the selection strength is constant at 0.8. Simulation B is where the mutation rate is constant at 0.3. Within each simulation, you're going to run 4 trials. And for each trial, you're going to alter one of the variables. When you run a scientific experiment, it is important to have multiple simulations where you keep most things constant so that you are only testing one variable at a time. Within each trial, you're going to run reproductive cycles. And after each cycle, you're going to see what do the blue grabbers look like. What is their mean phenotype? Phenotype has to do with the physical aspect. And again, we're keeping this simple. We are only looking at one physical characteristic. What is the length of that blue grabber? So what you will do is you will set your different variables. Then you will run your cycle and record after each set of cycles what the mean phenotype is. Again, why? Because the mutation rate is going to be measuring how much change is possible, and the selection strength will look at how the environment influences what happens with that mutation rate. So, Simulation A, how is that done? First, you'll be at your simulation with the biology in motion, and you're going to note that you start with the mean phenotype of 2. Right now, our current cycle is 0 because we haven't started. Then you're going to see that you have 3 go buttons. You can go cycle by cycle, and when you click that, you will see that the food comes down, a grabber eats, whichever grabber is eating, that's the one that's going to, in essence, be reproducing, and then, of course, it's reproducing to fill the spot where one died. Okay, notice we are now on current cycle 2, and our mean phenotype is still 2. So if we go another cycle, you'll see somebody died, this one reproduced, and again, we're continuing on. If you want to go a little bit further ahead, you can go and skip ahead to cycle 5, and you'll see that it's already done it for you. It shows you what the last one was, and notice here we're starting to see hunger levels. A hunger level in red means that it is not eaten for some amount of time. If it's all gray, then it's the healthiest. You'll see we are now at cycle 5, and our mean phenotype is still 2. If we went to cycle 50, okay, you'll see lots are starting to change. There's been some mutations here. See how this says mutations? There have been 3 that have increased the grabber or made the grabber go up, and 6 down. But overall, our mean phenotype is now changed, and you can see by the yellow the size. So you'll see if the prey falls over here, if you have a grabber of 3, you're more likely to grab it. This poor guy over here at 2, he's not going to be able to reach up as high to get the prey. So who has the potential to get it first? The bigger or longer grabbers. So you could go to 100, and now you'll see the mean phenotype is trending up towards 3.7. You'll see for this simulation we cap off at 4. And again, you can always go one by one just to see how things go. But the idea is you're going to continue to run this particular scenario. You're going to go through the cycles. You're going to record your data here. And then you will use that data to talk about how did things change. Did the mutation rate make things change faster? Did it make things change slower? If there's no change in selection strength, do you get any change down here? In the next part, I'm going to go through very specifically and show you how to change the different settings.